do some more calculus, and let's have a look at area. So I'm going to do y equals x squared. Our old friend. I've taken the slow plot off because I think we're okay on this now. Although a lovely test to do at this point is to make sure they know their basic polynomials. I've been into some quite senior classes and asked them now to draw y equals x cubed on their same graph. Well, you get everything. You know, you get that, you get that. You know, it's very, very common, even with quite so-called clever and advanced students. All right, I'll just rub out those bits. That's a diversion. Okay, let's put a point here and put a point here. Actually, I didn't really mean to do that there, and let's take that one up a little bit further to here. Okay, now I'm going to find the area between those two. Find area. Let's do rectangles above or rectangles below. Well, one of them goes up and then along, one of them goes along and then up. So it's your call. Let's do that. Fantastic. Now, obviously it's a dynamic area. I can do areas between curves and all sorts of things. If I select the area object, which at the moment is 2.387, I think I'm just a little bit out. Let's go there. 2.04, that's right. If I just select the area object, you see that the lightning's woken up. I can animate that area. Right, so once again I'm presented with a button to press, which is fun to press, but it's much more fun to think about before you press it. If I have 6 divisions instead of 5, is this estimate going to go up or down? Well, first of all, is it an underestimate or an overestimate of the actual area? At which point, if they've actually done some integration, and you can write on these things, it's not too difficult. Okay, what is the integral of x squared from 1 to 2? Well, I've done it before, and I'll tell you for free, it's 2.3 recurring. Okay, so 2.04 is definitely an underestimate of that. Now, obviously it is. Look at these big holes here. So, if you have 6 divisions, I think there are going to be one extra of these. The holes are going to start reducing, or they're going to, and so the estimate is going to be increasing. Let's have a look. Yes, perfect. All right, now this is a good time to suggest to one of your students to click on this button and to tell everybody else when it gets there. Now, you know it's never going to get there, so you can go off and have a cup of coffee and let them just click away. And then maybe by the time you come back, it's reached, say, 500. Let's have a look at that. Ah, what have we got? 2.33, are we there? Well, actually, we're 4 sig fig, aren't we? So let's just look at the page settings and change that up to, say, 10 sig fig. That's better. Oh, miles off, yes? Long way to go, yes, even though we thought we were there. All right. Now, what's fun to do is to zoom in. I just loved it. And this is really the critical time where I think you really can say, I could not have done this when it was just me and a piece of chalk. I think I did a pretty good job all those years with my piece of chalk with the clever ones, but I don't think I did as much as I can now do with the weaker ones. Because just to be able to see this, I think, is staggering. You get local straightness again, and of course you've got that going on, which is really lovely. And the show goes on, doesn't it? You know, just keep going. Now, Newton, bless him, was obviously looking at high ideals. And he didn't really think, well, actually, if we put triangles there, isn't the job done? Yeah? So let's do that and just see what happens. I'm going to double click on this and say, well, instead of this, I'm going to put the trapezoid rule. Ah. Oh. But it's not quite there, is it? It's still an overestimate, or is it? Now, what I should have done is asked, is it going to be an overestimate or an underestimate? Because I've now spoiled it. I'll cover it up so you can't see. All right, is it going to be an overestimate or an underestimate? Think of the curvature, all right? Think of it cutting the corner. It's going to be an overestimate, which means that if we zoom in on here, we should see the red curve appearing on the right eventually. Yes, let's see. Yes, there it goes. That's nice. Just silly little things like that you can slip in to add a bit of interest.